What's up guys, welcome back to Kit Guru. So today is a update on a project that I started several weeks ago, or maybe a couple of months ago actually, and it's about the EK 12th gen direct die cooling. You might have seen the first video, which was just taking some initial thermal tests with the CPU in its stock form and just showing you how the CPU was delidded. So today is a bit of an update on that, as I've got some of the initial prototypes from EK. So I know you guys have been really interested and been asking about part 2, so here is a quick update for you on what's going on. It might not quite be the update I was wanting, but I think there's going to be another video later showing how this all goes together and is working perfectly, hopefully. So what I've got so far is a custom block, a custom Velocity² block from EK. As you can see, it has a cold plate with kind of a raised section in the middle, and that is obviously what's going to be contacting directly with the CPU die. There's also some work done in changing the layout of the microfins in there. They've kind of been lowered down so they're closer to the die itself as well. So there's not a lot of change. So the base plate and the top of the Velocity² block is exactly the same. It's going to mount using the same EK exact mount, but you can see we have this raised boss, which is going to allow it to contact with the CPU die. Also, as well as the block, we also have the modified exact mount. So it still has a back plate, very similar to the stock solution, but on top now you have this CPU guard, which will replace the standard Intel clamping system. So this one, you can see here, is for direct die cooling. EK is also planning on releasing some kits. So for people that maybe just want to delid the CPU, add liquid metal, and then relid it and use it more or less stock, there's another exact mount, as you can see, same back plate, but it has a slightly different CPU guard on top, which allows, as you can see, if I just show you with this, it allows for space to use the stock IHS. So that's another kit that you can get, and I think also that EK are planning on releasing another kit for people that maybe are already using a standard Velocity² block and they want to convert it to a direct die block. So I guess that kit will include the exact mount, the CPU guard, and the cold plate. So I mean, this has all come about really from EK, from our original video. After seeing the response from you guys and how much interest there was in this, EK has really decided to bring out a bunch of retail products. So you're going to end up with a kit that will just allow you to do direct die, which will include the Velocity² block and the correct mounting frame. A kit, as I said, that will be designed for people that just want to delid, add liquid metal, and then relid. And then another kit to adapt a standard Velocity² block into a direct die block as well. I believe that EK is also working on a delid tool as well, so they will be able to offer the complete solution for delidding and direct die cooling Intel 12th gen CPUs. So these parts you can see are very early prototypes models. These have basically come straight off the machine and sent to us. There's actually only us at Kit Guru, EK, and one other YouTuber that has these parts and is able to test them. So it's still in very early development stage, and we're obviously testing alongside EK and sharing our results with each other to see whether this works and see what kind of improvement it's going to give us. So I'm going to show you quickly how the CPU guard is installed and how the block's installed, and then we can have a look and see if there is any improvement at all in the thermal performance, which we've been hoping for. I said this is not going to be quite the update I was hoping for, because I think already looking at this quickly, there might be a slight problem that maybe affects the thermal performance and maybe means that it's not quite what we were expecting straight away. But there is still plenty of scope for revising these products if necessary. So like I said, we're basically at the initial prototype testing stage with these, so we're not expecting everything to go perfectly straight away. So as I've already mentioned, these are just a very early prototype model, but they are likely to be very similar, if not identical, at least the mounting process or the installation process, as the final retail product. So I'm just going to quickly have a look at the installation process, and I'm going to be obviously using the direct die kit, as that's the one I'm going to be concentrating on later in the other video. So what you need to do first is remove the original Intel bracket. So I think the best thing to do is open it up and then remove the 2 screws at the bottom side of the bracket, and then the other torque screws on the top. Be very careful not to drop a screw into the actual CPU socket and bend any pins, because that could be the end of the motherboard. And then you can see there's a back plate there. What I've noticed, or one of the first things I noticed about this EK Exact mount, is that it didn't come with any gasket to protect the bottom of the motherboard from the base plate of the Exact mount. As I said many times, this is a prototype. It's likely that the final retail ones will come with some kind of gasket, because there is some circuitry there that the Exact mount could potentially touch. Although this is anodized, so technically it shouldn't be conductive, but the original stock Intel backplate, that does have a gasket on, and I'm just going to peel that off and reuse it for now on this EK Exact mount. So I'll just pop it on the correct way around, and it lines up with the same mounting hole, so that's good. And then we can just pop that in place and just flip the motherboard back over, and you can see that lines up pretty nicely with the LJ1700 holes, and this actually only goes on one way around. The spacing on the screw holes is different on the top and the bottom. So what you need to do next is take your delidded 12900K or any 12th gen CPU, pop that into the CPU socket, and then put the CPU guard in position. And then there's some small Allen head screws. Just pop those in place, make sure everything lines up before doing any final tightening. These are only a 2mm Allen head, so you don't want to be tightening them up too tight. Just nip them up. That's the Exact mount and the CPU guard fitted. Really easy installation process that is, and you can see you've got a nice space with the bare die showing. And then all you really need to then is put on your thermal paste, ideally liquid metal. I think this is designed to work best with liquid metal. And then just drop the block in position, turn it round, and then start tightening these up. And as I say, the best way to do it is always equally with even pressure, tightening up just a few turns at a time, working from each corner, if you will, until you got it sufficiently tight. So that is basically the installation process. Obviously you've got to connect up your fittings, and if you want the RGB lighting, install that to your motherboard or wherever you want to install it. But it looks like a pretty straightforward installation process. So as I mentioned earlier, I did find a slight problem with this early prototype version. When you are tightening the block down, you actually find that before it makes good contact with the CPU die, or the cold plate makes good contact with the CPU die, the plate actually fouls on the CPU guard first. So I did some initial testing with just some regular thermal paste, and we were getting really poor contact, and obviously instantly as soon as any load was put on the CPU, temperature was really high. So there is going to be a revised version of this kit. We should be getting a sample of that pretty soon, hopefully within the next few weeks. So I think the plan or the way EK is going to revise this, is by making the boss on the cold plate protrude out more, or making it taller, so then it will give you slightly more clearance between the CPU guard and the cold plate, and hopefully then we should be able to give these a proper test. But for now, what I'm thinking of doing, I've actually tried to mount the CPU block without the CPU guard in place. That was really awkward. It was very difficult to get the block flat and square on the CPU die. But what I'm going to try and do now is I'm going to try and grind down the CPU guard slightly using a sander to just give me a little bit more space between the CPU guard and the water block. And then I'll put it back together, maybe even put it back together with some liquid metal, give it a try and see if we get any improvements in performance. Okay, so what I've done is I've ground down the CPU guard by between 0.2 to 0.3 millimeters across the whole top surface of the CPU guard. And now, as you can see, the thermal paste spread is a lot better than it was. I didn't show you the thermal paste spread before, but there were some areas of the die that weren't even covered. The mounting pressure was so low they hadn't even spread the paste across the whole die. So I'm hoping now I should be able to clean off this paste, put a bit more paste on just for another test fitting, and see if the system posts, because before there was such little mounting pressure with the CPU guard as it was before it was ground down. The mounting pressure was so low that the system wouldn't even post. So I'm going to clean off that paste off the block and off the CPU die, put a bit of regular paste back on again just to test fit and see if the system posts. So the test system's set back up exactly the same as it was before, with the quick disconnects and the radiator setup. Everything's exactly the same as it was during the initial testing in part 1. The guard has actually been ground down in some places by about 0.4 millimeters. I just checked it on the vernier calipers and I noticed there were some high spots, so I've just ground it down a little bit more, and now we'll see if the system posts, because before, with the CPU guard as it came, the system wouldn't post at all due to a lack of mounting pressure. So I just switched the HDMI input on the monitor, and then we'll see if it posts this time. Okay, it looks like we might have something this time. There we go. So system post, I'll just go into the BIOS and see what's going on. So the CPU's registered, frequency is at 4.9 GHz, ratio 49 times, so that looks like it should do. Core voltage of 1.24, memory looks good, reading all the full 32 gig of memory, so that looks okay. So what I'll do is I'll just try and load up the stock 12900K profile that I had previously, which enables the XMP profile and certain voltage tweaks that I did. So I'll just load that profile and see what happens with that. And see if the system will restart with that profile loaded. I'm just looking at the postcode display on the motherboard here, and it looks like it's stuck in some kind of boot loop, so it doesn't seem to like the profile that we had running on the system earlier with XMP enabled. So I'm just going to power it off again. And then just give it a restart. This should reset the BIOS settings, I think, back to default, because it's failed to post. It went through the sequence a few times and failed to post, so hopefully it should post this time with the default values in the BIOS, I think. Okay, so it looks like it's going to post again this time. You can hear the radiator fans have Come on, and we've got a post again, and you can see that it's in safe mode. So hit F1 and go into the BIOS again. This time I think what I'll do is just load optimize defaults, and you can see that the XMP profile is, well, it's on auto, but it's off at the moment. We'll just do a reboot now and see if it'll post again like that. Just want to get into Windows and see what the temperatures are doing with this system as it is, with the CPU guard ground down. Remember, at the moment we're just using some regular thermal paste, so I'm not expecting any major improvement in the thermal performance, although who knows. So I'll see if it'll post now with XMP turned off. I think it should post this time, looking at the postcode display. Looking good. So there we go, we've got a post and it looks like it's going into Windows. So once it boots into Windows, I'll have a look and see what kind of temperatures we're getting. I'll run a quick Cinebench test and see how it's performing. Okay, so we've got HW info open here, and at the top bar is the CPU vCore, and then the second one down is the CPU package temperature, and then the third one down is the CPU package power. Cores are looking like they're acting or behaving correctly for the moment, and with the system idling, the P cores are idling between 25 to 30 degrees, which sounds pretty normal. It's quite warm in here today. We're having a bit of a heat wave in the UK, so the ambient temperature in here is about 25 degrees at the moment. So on idle, it's looking pretty good. Some of the E cores are down at 24 degrees. So we're looking between 25 and 30 degrees on idle, which looks normal, but it all depends on what happens under load. So I'll just set the Cinebench R23 stability test, so this should run for 30 minutes, although I don't think I'll be running it for that long, and use the multi-core test. So just set that going and let's see what happens. So quite quickly the fans on the radiator have ramped up, and you can see temperature on one of the P cores is already 87. Just make this a bit bigger. See the max here is 88 on one of the P cores, which sounds pretty high to say that with direct die cooling. Got 89 on one of the P cores. So I'll leave this test running and just see what happens. So we've only been running the test about 5 minutes. Already you can see that the hottest P core has hit 93 degrees, which is pretty hot. CPU package power is around about 220 to 225 watts. The package temperature currently is about 91 degrees, which again isn't very impressive for direct die cooling, but remember we're not using liquid metal at the moment. vCores are at 1.25 volts, so not looking great at the moment, and still the XMP profile is not working either. So I think what I'm going to do is stop this test, shut the system down, disassemble it again, maybe take a bit more off that CPU guard, grind that down a bit further, and then repaste it, put it back together, try again. Okay, so here's where we're at now. You will have seen that I took about another 0.2 of a millimetre off the CPU guard with the belt sander. I then insulated the SMD capacitors on the CPU with some nail polish. I've gone straight for the liquid metal this time because I didn't think we'd see any difference using regular thermal paste. So we've got liquid metal on there, everything set up as it was. Again, we're still not being able to post with the XMP profile for some reason. I still think we need a bit more mounting pressure. We have the system up and running again, running the Cinebench stress test or the Cinebench stability test. You can see that's running there, and there is a very noticeable difference now in the temperatures. Before, where we had the P cores number 3, 4 and 5, they were in the 90s. Now we're seeing 70 degrees on those P cores, so sorry, not 70 degrees, but in the 70s and touching 80 degrees. So there's a very significant improvement in the temperature of those P cores. We've still got a bit of a difference with one of the P cores. That's maxing out at about 84, 85 degrees. But you can also see package power now is down at around between 205 to 210 watts, where before it was around 220 to 225 watts. So with the CPU running cooler, it's brought the package power down a bit. And you can see package temperature now is around about 84 degrees, which before it was up around 92 degrees. So there's potential here, definitely. We're seeing some potential with this EK direct die cooling kit. It's not perfect yet. We will, like I said, be getting a revised version soon, which I think will have a taller cold plate. So that should basically do the same thing as what I've done here by grinding down the CPU guard. So although it's not perfect at the moment, we are seeing some improvements, which is promising, and hopefully with the next revision we will be looking at perfection. Hopefully, that's what we're hoping for anyway. So it's looking okay so far. There's potential in it, but we're not quite there yet. So thanks for watching, guys. I hope you've enjoyed this part 2 video of the EK Intel 12th Gen direct die cooling project. If you have, don't forget to hit the like button, subscribe to the channel if you like the content. Let us know what you think to the project or how it's going so far in the comment section. And if you want to help support Kit Guru, if you like the content that we produce, don't forget you can head over to our store and pick up some of our merch. You can even subscribe to our Patreon. And as always, if you want to catch up on all the in-depth technical reviews, head over to the website.